Dear students, welcome to this session. This session we will discuss the formation of octahedral complexes on the basis of valence bond theory. So, the formation of outer and inner orbital complexes by taking example hexacyanocobaltate 3 complex ion, hexafluorocobaltate 3 complex ion. Let us take the formation of hexacyanocobaltate 3 complex ion. So in this central metal ion is cobalt 3 plus ion. So the oxidation state of the cobalt is 3 plus. So atomic number of cobalt is 27. So electronic configuration is written as argon configuration at atomic number 18, 3d7, 4s2. So outer electronic configuration is 3d7 4s2, which is represented in the box diagram 3d7 4s2. So to form cobalt 3 plus ion, metal loses 3 electron. So outer electronic configuration of the ion will be 3d6 with a loss of 2 4s electron and 1 3d electron. So now configuration is with 3d6. 4s orbital will be vacant. Now when cyanide ligand approaches the metal ion, so it influences such that the electrons in the d orbital will be paired up. So all the electrons will get paired up. Now two vacant d orbital will be available. So now the metal ion undergoes D2sp3 hybridization using two vacant 3d orbital, one vacant 4s orbital, three vacant 4p orbital. So after hybridization, it gives 6 D2sp3 hybrid orbitals of equal energy. Now each D2sp3 hybrid orbital will overlap with filled orbital having lone pair of electron of ligands to form 6 coordinate ligand metal bond. So 6 pair of electrons will be from 6 cyano ligands. So is the structure of the complex where 6 ligands are forming 6 coordinate bonds with central metal ion. So the geometry of the complex is octahedral. It is inner orbital complex since it utilizes inner, that is n-1 d orbitals for d2 sp3 hybridization. Also there are no unpaired electrons, so the complex is diamagnetic. Let us consider the formation of hexafluorocobaltate 3 complex ion. So in this complex also central metal ion is cobalt 3 plus ion. So the outer electronic configuration of cobalt is 3d7 4s2, which can be represented in the box diagram 3d7 4s2. So cobalt 3 plus ion will be formed by the loss of 3 electrons. So its outer electronic configuration is 3d6. Now when fluoroligands approaches central metal ion, it does not influence pairing up of electrons. So there are no pairing of electrons in 3d orbitals. So now the central metal ion undergoes hybridization, but here it undergoes sp3d2 hybridization. So d orbitals or outer orbitals, that is 4d orbitals, are utilized in hybridization. So one vacant 4s orbital, three vacant 4p orbital and two vacant 4d orbitals are utilized in hybridization. So after hybridization, it results in 6 sp3d2 hybrid orbitals of equal energy. And each sp3d2 hybrid orbital overlaps with an orbital having lone pair of electron from fluoride ligand to form 6 coordinate bond between ligand and metal. So 6 pair of electrons from 6 ligands. So is the structure of the complex in which 6 coordinate bonds are found between ligand and the central metal ion. So the complex is outer orbital complex since it utilizes outer Nd orbital for hybridization. Also, in this there are 4 unpaired electrons. So the complex will be paramagnetic in nature. Also, it is high spin complex. Thank you.